Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. I'm just here to let you know that Julien Riposo, as one of his resources, recommended this amazing book that could get you a head start or a jump start if you are interested in learning blockchain or anything quant related. So that will be linked in the description for those of you who are interested in getting a head start. Hello, I'm here today with Julien Riposo, who is currently a mathematician and researcher, who is working at the London Stack Exchange Group. So if you would like, could you please sort of introduce a bit more about yourself, as well as share your story to sort of how you got to where you are today?
Yeah, of course. Thank you very much for the invitation, and hi everyone. It's a pleasure to share some experience, and hopefully you will find that useful. Really. Um, so look, well, as you all know, I'm Julian, and I started my studies in theoretical physics. Well, actually, I come from what we call nowadays the Sorbonne University, and I've been just traveling between Sorbonne and the Paris-Saclay. I did in particular, my PhD in applied mathematics in a theoretical physics lab, actually. And there I started to, what I did is some study around data analysis applied to biology and finance, right? So I wanted to make this connection because actually my career was mostly oriented towards an academic researcher position, but then I didn't want that. I decided to connect somehow with finance and then to gain some knowledge here and to, of course, prepare for integrating this industry community, the finance one. So then I have, after my PhD, managed to get to finance, and here I had several roles in finance. Started as a quantitative analyst, and then I just, changed companies, and I evaluated in my throughout my career. And nowadays, I am working at London Stock Exchange, where I'm a digital asset quantitative researcher, and I have a profound interest towards mathematics. Right. So you see, I started in academic, but then I joined the industry, the finance industry. Possible.
Thank you. Were you always interested in mathematics? Was this something like you knew you were going to do when you were like in high school or like in middle school?
Yeah. So frankly, when I was 10 years old, I had developed, since my 10 years old, let's say, a passion for physics and chemistry and physics, biology as well. Um, and you know, mathematics were not my initial, let's say, passion, but I was still very interested in that. But then throughout my, studies, I have developed more and more this fascination for physics, and the passion for mathematics arrived throughout this devotion towards physics. Um, but the maths were always present in my life. Yeah, so I worked very hard on math because it was difficult, and it's still difficult. It's difficult for everyone. So it's quite normal to find this hard, but that's that's where passion is coming from.
And then I think you mentioned you originally studied math and a little bit of biology. What was the like inspiration behind applying math to finance?
So when I was doing my master's degree, I discovered this. lessons uh, about statistical physics applied to finance and financial markets more specifically. I was just saying, wow, what the hell does it mean? Because I was, studying theoretical physics, chemistry, biology, as you said, and all this was only on nature, right? Um, I was wondering, I was very curious. Okay, so we have some very technical mathematics applied elsewhere, right? Not just nature, but elsewhere. So let's figure it out. And I was very blown away by the whole thing, right? So I then just decided to follow that direction.
And then I think you mentioned you're currently a quantitative like analyst or quantitative researcher. What's been your like most favorite as well as most challenging part of your job?
Right. So I really find that there is one thing which I really find fascinating about my job is, or this universe, more generally speaking, is the interaction of very concrete economics and finance with mathematics, right? So you can have a vision and you can have even, hopefully, a solid vision of economics and finance by means of mathematics, right? And I find that quite thought-provoking all the time. So it's uh, it's really like universal point of view, I would say, in the sense of yeah, there are some maths which allow to construct models, and these models can, to some extent, explain some parts of our world in from an economic and finance point of view. So that's the very fascinating, and there is the research aspect as well. I would say, I have to say, uh, there are many unanswered questions nowadays, in particular in the world of crypto. And there are a lot of things in the world. There are a lot of things to do in the world of crypto. That's really like, you just you're just discovering you're just opening a door and you're discovering a brand new world, which is almost empty and which is really looking forward being populated, right? So that's something which is very attracting, my opinion. So now to your second question, what are the things the most challenging? Um, I want to say everything. Um, Everything is a challenge. So it can be, the mathematical problem to solve itself from technical point of view. Um, if you discuss with people, they are mathematician or not whatsoever, people in finance, they have there are problems. Okay, there are problems, there are business problems, and they don't necessarily know how to solve that, right? So what I'm doing is listening a lot. I'm discussing a lot. I'm with many people everywhere, right? From different directions, and uh, if it's about solving the business problem, then you set the equations, right? To some extent, you mathematize the problem. You set it to a rigorous as much as possible problem. You set a math problem and you try to solve it. If you can't solve it, then you just try to make some assumptions and to try to find some things to say about the solution, and you test it from numerical point of view, so from simulation point of view and all that. You get inspired from your simulations to derive the mathematical proof of the statements you wanna make. So all this is challenging. There is also another challenge, which is um, you know, communication. As I told you, I'm not necessarily having a background in finance from educational point, from a study point of view. So I had to catch up with everything at the time, right? And you have to some extent speak the same language of the community if you want to be included in that community. So that part is very challenging, communication with others. And I want to say, even nowadays, for everybody is the same problem, get understanding each other. Right? It's not necessarily my case personally. It is like the case of everyone, but understanding the specific language, understanding specific way of saying things, all of that is very challenging. So I I would really recommend you guys to ask questions and not be afraid of asking questions. There's no stupid question, right? So ask them.
Thank you. And then I think you mentioned before that no matter how hard something is or how challenging something is, like your passion overcomes that challenge. I was just wondering if you could explain a little bit more, like when you face a challenge or when you're really, really stuck, what exactly do you do to overcome that challenge?
Right. That's good. Um, I like these kind of questions because actually, when you are doing mathematics, you are stuck all the time, right? You are stuck all the time. Really, I'm not overstating it. You are really, really stuck all the time. What is being stuck? So, as I mentioned earlier, you have a problem. You have a mathematical problem that is the business problem to solve, right? But you, for instance, you don't know how to do, or you have tried some leads, but they all failed. But yeah, it's not a failure to some extent because from every failure you learn something. You know it's not the right direction, and you can understand why it's not the right direction. So if it's not the right direction, you have to understand why. What can I do with that? So you can simply make some new assumptions to reach the goal, right? So you make an assumption, you supposing something is true, and you cannot prove that this thing is true, but make this assumption and test this assumption, right? And then if you manage to get to the goal, that's very good. But and if not, then try again. I mean, you know, it's it's very open. Mathematics in research. There's no way. There's no known. There's not known way to solve an unsolved problem because it's unsolved, right? So it's you choose the way to solve it, right? So you make the assumptions and you try to test them. If they are realistic, then you have to prove the assumption somehow, right? And then it's a turn around and around, right? You solve something, you prove something, but you have used an assumption, then you have to the main thing to do is to prove this assumption, right? So the story starts again, right? Starts again and again until reaching, you know, a sufficiently self-consistent way to answer the problem. And then what you can do is just you can publish articles as we do, as I do, and books and all that. So yeah, it's it's really it's really difficult, but it's so amazing. It's so amazing. Yeah, it's a great pleasure, and it's a great pleasure as well to find a solution. But itself, without finding the solution, it's a great pleasure to. And I mean, you become obsessed to some extent when something is difficult. You think about it, and you sleep at night, and the day tomorrow, you say, "Wow, I know I dreamt of it. I know I dreamt of it." Right? So you write down the equation. Very often, I would say, I wake up at night and I think, "Oh, wow, I have an idea." I write down the equation. I write down the idea. I go to sleep, and tomorrow I have another possibility to explore. You know. So really, you know what? I think to sum this up, you need to be fascinated and passionate for what you do, because otherwise, what's the point? You have to find your you have to find your road, I would say, and it has to be something you really, really, really like. Right? Perhaps before money. Yeah, perhaps before money. You have only one life. All right.
And then, sort of to end off on the same note, do you have any advice, recommendations, or suggestions for high school students or just any students who are interested in pursuing math or finance or any of the fields you pursued, like physics, biology, chemistry, in the future?
Yeah, of course. Yeah, yeah. I would have a recommendation is, well, I have two recommendations. The first one is, do you really like it? Right. You really like it, and yeah, you have to think about that at some point. It's not just about being good at that. Because being good, what does it mean? It means that you are directed by your passion, right? It's not necessarily about competition, I would say, because I know we are in a world, and I've gone through this. We are in the world where competition is all the time there, right? But if you want to be bright, if you want to be good in science, in math, and all that, I don't believe this is competition that gives the thing. Competition, yeah, okay, it helps obviously having an economic system and companies to surpass their abilities and to be better than another one. But I'm not talking about that at all. I'm talking about the intellectual uh, success, right? The intellectual success. I don't think it's competition. I really, really believe it's passion. So if you find math really fascinated and that you really, really enjoy that, really, really enjoy searching for a solution, being stuck and searching for a solution, then yeah, go ahead. I mean, yeah. And maybe another recommendation is how this is very important to be sufficiently good in math. Because look, if I have managed to go to the finance community, it was thanks to my hard work in math, right? And it's more, let's say, it's more easy to change direction if you're good at math, right? Because you have more possibilities in industry right now. Look, we hear a lot about machine learning and AI and all this stuff. It's well present in the industry. Um, you have to be good in programming and all that, but if you're good at math as well, it's really, really a bonus. Yeah. So I want to say, be really use your passion, and be passionate about math, about this. Not necessarily math, but yeah, if you have a passion, just go ahead. I mean, yeah, try and go ahead because you need to love your life, right? You need to love what you're doing every day. You need to love that, right? Let it be math, biology, whatsoever, right? So once you found your road, yeah, you're sure you want to do that. And it's not just, oh, I thought about this, yeah, I want to do that. No, no, it's something that is in deep down inside, really in your blood, right? If you like it, then go ahead.
Okay, thank you so much for coming to the call and talking with me. It was absolutely phenomenal.
My pleasure. I really, really hope that you guys find that useful. That's my only goal here. And good luck. And if you want to reach out, feel free.